This multi-ton steel structure failed because of MIG welding spatter. This multi-$1,000 medical-grade container was scrapped because TIG welding was too slow. The problem wasn't the welder's skill. It was the wrong choice from the very start. In this video, we're settling the debate, MIG versus TIG, and we're giving you the framework to choose perfectly every single time. Let's break down the fundamentals. Both use an arc and shielding gas, but the electrode is the key difference. MIG, or metal inert gas, uses a consumable electrode that spool of wire feeds continuously. Melting into the weld, it's semi-automatic fast, and uses a mixed gas. TlG, tungsten inert gas, uses a non-consumable tungsten electrode. You hand-feed a separate filler rod into the puddle. It's a manual ballet of heat control, using pure argon to protect sensitive metals. So, which one wins? It depends on the category. Strength. A properly executed MIG weld on a prepped joint can be stronger, but TIG's precision leads to fewer defects, making it more consistently robust. Speed. No contest. MlG wins. Continuous wire feed means it's dramatically faster for long beads and production work. Aesthetics. TIG wins. It produces those beautiful, clean, stacked dimes with no spatter. MlG can be neat, but often requires cleaning, cost, and learning. MIG is cheaper to operate and far easier to learn. TlG requires a significant skill investment and often has higher equipment costs. Here's the cheat sheet. Save this screenshot. If your primary goal is speed on long, thick steel, seems MIG wins. If your goal is a perfect, splash-free finish on a thin aluminum masterpiece, TIG wins. Your material dictates your process. Carbon steel, MIG is the king. Stainless steel, it's a Titanic for beauty and thin sheets. Pulsed MIG for productivity on thicker parts. Aluminum, titanium, copper. TIG is the undisputed champion for everything but the thickest aluminum plates, where MIG takes over for efficiency. Choose MIG when you're working with thicker materials, need to lay down long, continuous welds, are working in difficult positions outdoors, are in a production environment where speed equals money, or if you're a beginner just getting started. Choose TIG when you're working with thin materials that could warp or burn, welding exotic metals like aluminum or titanium. The project requires a beautiful, visible finish. You need ultimate precision and control over the weld puddle, or have extreme purity requirements like medical or food grade. Theory is great, but let's get real. A medical device company needed a sealed 316L stainless steel housing. They initially wanted MIG for speed, but our analysis using a simple framework of material, thickness, quality, and efficiency showed it was a perfect TIG application. The wall was only 1.2 millimeters thick. It required 100% air tightness and a clean, splash-free interior. The result? A perfect weld that passed all tests, avoiding costly leaks and rework. Speed is meaningless if the part fails. Let's tackle your biggest questions. Can you MIG weld aluminum? Yes, but it requires special, expensive equipment and splash control is tough. For most, TIG is better. Is TIG really that much more expensive? Per hour, yes. But for precision work, you save a fortune on polishing and fixing mistakes, making the total cost competitive. Which should a beginner start with? MIG. 100%. It's more forgiving and easier to learn the basics of arc and travel speed. So, is MIG better than TIG? No. There are different tools for different jobs. MIG is your reliable workhorse, fast, strong, and efficient. TIG is your master's scalpel precise, beautiful, and specialized. The best process is the one that best matches your project's specific needs. Don't guess. If you're working on a critical project and need expert guidance, reach out to the pros at JS for a consultation. Hit like if this helped. Subscribe for more metalworking wisdom, and let us know in the comments what you're building.